All right, today we're going to factor quadratic expressions, and this is found in section 4-4, part 1 of your book. So again, our objective is to find common and binomial factors of quadratic expressions. So here's just a little bit of vocabulary. It says a number that divides evenly into a given number is a factor of the given number. An expression that divides evenly into a given expression is a factor of the given expression. Factoring is rewriting an expression as a product of its factors. So let's talk about that. In example 1, we are asked to factor we are asked what is the expression in factored form. So what can this expression be rewritten as in factored form? So here's the deal. The first one, x squared plus 9x plus 20. In order to, and I'm going to teach you one way that will work for many ways. In fact, just about all of the ways that we will deal with factoring expressions. There are shorter routes, so I'm going to go ahead and acknowledge that first. There is a shorter method and a shorter way of doing this. However, I'm going to teach you the way, that way I can teach you the same way for the rest of the factoring that we're going to do. All right, so in factoring, the first thing you want to do is identify your A, B, and C. Notice we have our standard form at the top. So A, B, and C of the first one is 1, 9, and 20. Okay, so what we will do, I call this the AC method. So the AC method would then tell me to multiply A times C, which is the same thing as 1 times 20. So that gives us 20. We would then list the factors of 20. Now I do this starting at 1. Just so I'm clear that I've listed everything. So I would have 1 and 20, 2 and 10. There are no 3s, but then there's a 4 and a 5. Okay? And our goal now is to figure out which of these factors as a combination would add up to 9x. Meaning what we're trying to do right now is replace our center 9 with two numbers. So what two numbers can we replace 9 with? And it should be, and you should see that it's 4 and 5. So this is what we do now. We'll write x squared and we'll write 20. They are the first and the last. Okay? And next, we're going to write 4 and 5 as a replacement of 9x. Well, 9 is what we're replacing, but don't forget that the x has to be attached to it also. So when I rewrite it, I'll have 4x and 5x in the center. So again, 4x and 5x replace 9x. Okay, moving past this step, we group the first two, group the last two. And then from here, I need to know what my greatest common factor of x squared and 4x. So what do x squared and 4x share in common? They both share x in common. What's left over, meaning if I divided x squared plus 4x by x, I would have x and 4 left over. Next, in the second set of parentheses, I need to see what group I have here. What is the greatest common factor of 5x and 20? And we should see that it's 5, and that is a positive 5. And then again, we write what's left over, which is x plus 4. Guys, at this point, we should notice that our parentheses are the exact same. If the parentheses are the exact same, you can copy one of them. So I'll have x plus 4. If you know the other factor is what's going to be on the ins or outside of the parentheses, which is x plus 5. And those are our answers. All right, the next one, AC. Again, we need to identify our A, our B, and our C. So A is 1, B is 14, and C is negative 72. Okay? A times C will give us negative 72. So we need to go through and find all the factors of 72. So just a moment while I get my calculator ready. So that's 1 and 72, 2 and 36, 3 and, let's see, 3 and 24. 4 and 18. There's no 5s. There's 6 and 12. I don't believe there's a 7, but there is an 8, and it's 8 and 9. So again, we need to ask ourselves what combination of factors will give us 14. What you should notice is that the combination that will give us 14 is going to be 4 and 18. But you may say, well, how? How is it that they can give you 14? Well, the deal is, remember that these factors had to be multiplied together to give you negative 72. So in other words, 4 or 18 must be negative in order to give you 72, negative 72. So what we will have is that 18 is positive, but 4 is negative. So we're going to go ahead and replace 14x with negative 4x and positive 18x. So let's do that. So remember, you write the first one, which is x squared, and you write the last one, which is negative 72. And then we're going to put negative 4x. Oops. So negative 4x plus 18x in the center. All right, so again, you can go ahead and group. So group the first two and the last two. I can take an x out of the first set of parentheses and have x minus 4 left over. I can take an 18 out of the second set and still have x minus 4 left over. So remember, the parentheses should be the same, so that's one of our factors, so that's x minus 4. And the other one is what's left on the outside, which is x plus 18. And this is our final answer. We have one more to do, so I need to clear everything off of this screen so that we can see the last one. I'm just going to go ahead and erase. And so I probably won't erase everything, I'll just erase this last one. Okay, so again, we want to identify A, B, and C. So A is negative 1, B is 13, C is negative 12. Okay, A times C will give us positive 12. So the factors of positive 12 are 1 and 12, 2 and 6, 3 and 4. Okay, so again, we need to ask ourselves what combination is going to give us 13, and I hope that we see that the combination that's going to give us 13 is 1 and 12. Okay, so let's go ahead and start rewriting. So we have negative x squared and we have negative 12. But remember, we're replacing the 13x with 1x and 12x. Okay, now we need to group the first two and the last two. So at this point, we need to ask ourselves, what can I factor out of negative x squared and positive 1x? It doesn't seem very obvious, but you can actually factor out a negative x. I'm then left with x plus 1. On the second one, I can factor out a 12. And again, I'm left with x, or actually, let's go ahead and factor out a negative 12. So let me fix that. And you're going to see why I chose to do that. So I can factor out a negative 12, and I'm left with x plus 1. The reason I factored out a negative 12 is because I wanted to be sure that our parentheses would be the same so that it's an actual factor. So x plus 1 is a factor, and the other factor is going to be negative x minus 12. However, this is technically not fully factored. Reason being, this negative, there's a negative that can be factored out of both of those terms. So really our final answer is, if I take the negative out first, I have a negative. And then if I take out the negative from the negative x minus 12, I'm left with x plus 12. And then finally x plus 1. And that's going to be our final answer. All right, and try 1. Again, we need to identify our A, B, and C. So A equals 1, B equals 14, C equals 40. AC would give us 40. A times C, 1 times 40 is 40. So that's 1 and 40, 2 and 20, 4 and 10, 5 and 8, and that's it. Okay, the factors, remember we're trying to replace 14, so the factors that will replace 14 are 10 and 4. So So let's write the beginning. So we have x squared and we have a 40. Okay, then we need to replace it with 4x and 10x. So 4x and 10x. Okay, we're going to group and group. And so I can take from x squared and 4x and x, and I'm left with x plus 4. The factor that is the greatest of 10x and 40 is 10. And I'm left with, again, x plus 4. So I did well, okay? I have those factors are the same, so x plus 4 is one of the factors, and the other one is x plus 10. And we're done. Okay, let's move on to the next one. So let's go ahead and deal with this negative from the very beginning. If you notice that you start out with a negative x squared, you can actually factor it from the beginning. So technically, I hate to kind of do that, but actually, you know what, let's not. And I'll show you at the end. So again, A is -1, B is 14, and C is 32. Okay, A times C will give us 32. So the factors of 32 are 1 and 32, 2 and 16, no 3s, but 4 and 8, no 5s, no 6s, no 7s. Okay. And so the factors that will somehow give us 14 are going to be 2 and 16, but we have to figure out how. And by the way, this should be -32 because that's negative. I mean, nope, that was positive. Okay, so we have to figure out what factors give us 14, and it's going to be 2 and 16. But since it had to be -32, then that means either 2 or 16 is going to be negative. And the one that's going to be negative is 2, because 16 minus 2 will give us 14. Okay, so here we go. -x squared and 32 still go in their spots. And then I have -2x plus 16x. Okay, we're going to group the first two and the last two. I can take from the first one a -x. I'm then left with x plus 2. Then from the next one I can take a positive 16, and I'm still left with x plus 2. That's great because x plus 2 is what I wanted, so I have an x plus 2. And then I have what's left over, which is -x plus 16. Again, we tend to not have x as negative, so I need to, once again, factor out this negative from this x. So the way I'm going to do that is I'm going to go ahead and take out the negative, and then that changes the sign of everything. So in other words, I just divided this whole factor here by -1. And so that leaves my factor as positive x and -16. And then the other factor is going to be x plus 2. And we're done. So we've already kind of talked about greatest common factor. So it says the greatest common factor of an expression is the common factor of the terms in the expression with the greatest coefficient and the greatest exponent. You can factor any expression that has a GCF not equal to 1. So let's take a look. So in example 2, it says, what is the expression in factored form? So in other words, we need to find what the greatest common factor is and then factor that out and then rewrite the rest of our expression. So for example, 6n squared, if I broke that down into its basic factors, I would have 2, 3, and 2 n's. Okay? If I broke down 9n, I would have 3, 3, and n. So the greatest common factor is the greatest amount of factors that they share in common. So they have 3's in common and they have n's in common. So if I have their greatest common factor as 3 and n, that means their greatest common factor is 3n. So 3n is the greatest common factor, and now I just write what's left over. What's left over of the first one is 2 and n, so that's 2n. And what's left over of the last one is 3, so plus 3. And this is our answer. Okay, let's look at the next one, 4x squared. If I break down 4x squared, that's really 2 times 2 times x times x. If I break down 20x, that's going to be 2 times 10, right? And 10 is 2 times 5, and I still have an x. And then -56, we need to take out the -1 first. And then 56 is even, so I can divide it by 2. So 2 times 28 gives you 56. So now I need to break down 28. 28 is 2 times 14, and 14 is 2 times 7. Okay, again, we want to circle what they have in common, so they all share a 2 in common, and that is it. So the greatest common factor here would be 2. So if I rewrite this just as dealing with the greatest common factor, I would take a 2 out, and I'm left with whatever is left over. So what's left over is 2x and x, which is 2x squared. What's left over of the next one is 2, 5, and x. That's 2 times 5 times x, which is 10x. And the last one is negative 1, 2, 2, and 7. Well, if I multiply that all together, that's 7 times 2, which is 14. 14 times 2 is 28, so that's negative 28. And that would be our final answer there. Okay, we're going to do this one more time with try 2. So again, we're going to start with our GCF. So 7n squared, if I break that down, I get 7 and 2 n's. Negative 21, if I break that down, I get a negative 1, a 3, and a 7. What do they share in common? They share a 7. So 7 goes on the outside, and then what's left over of the first one is n squared. What's left over of the second one is negative 3. And so that's our answer for that one. The next one, 9x squared. If I break down 9x squared, that's 3, 3x, and x. 9x is 3, 3, and x. And then negative 18 is negative 1, 2, and 9, and then 3 and 3. Okay, they both share 2 sets of 3's, and that's it. So 2 sets of 3's, remember, is 3 times 3, which is 9. So I can factor out a 9 from the first one, and what's left over is x squared plus x minus 2. And that's it, guys. If you need any help, come see me for tutoring.